and welcome to our live Solution Series event today. My name is Matt Hummel, and I'm the Product Manager for Valves, Actuators, Dampers, and Power Meters at Alps Controls. I'm excited that you've joined us today to learn about the Danfoss ABQM Pressure Independent Control Valves. And real quick, before I get started, I want to mention that we do have a Q&A session right after the presentation. If you have any questions, just click on the Q&A button at the bottom center of your screen, and a window will pop up where you can enter and submit your questions. We'll answer all the questions that we can before our event's over, and if we don't get to your question, just make sure to include your name with your question so that we can follow up with you afterwards. We're ready to go here, so I'll turn this now over to Stanley. He's our Danfoss application expert, and today he's joining us from the Netherlands. Thank you again, everyone, for joining us today. We'll be back for our Q&A in just a little bit. Stanley, the show is yours.
Yeah, thank you, Matt. Thank you also on behalf of me for joining. As Matt was saying, I'm Stanley de Vries, and I have been a long-time Danfoss employee in many functions, but right now I'm an application expert for our hydronic systems. And today we will talk to you about ABQM, pressure independent control valves. US guys tend to want to call it PICV, which I also think is okay. But first, let's talk about Danfoss for a bit. Danfoss is actually a quite big Danish company with a lot of different products and different divisions. We tend to be kind of like a solution, or let's say a component supplier, and we also have some solutions, but we work. One of the things that we have is the Power Solutions division that is about hydraulics mostly. So and also for big building machines, like Caterpillar is a big customer there, for example. Then we have on the other side, we have power electronics and drives. I think specifically if you're from the HVAC world and doing controls, you for sure know our drives. Because they're also market leading in this area. And we have also many solutions there surrounding solar energy and other solutions. And then the middle one, that's climate solutions, that is my division. And here also we have quite a lot of different products and solutions. One is also very famous are the compressors, so for cooling, and we have controls and thermal management as well. That means that we have valves that we sell also to a lot of chiller manufacturers, for example. So this is very much also an OEM. Let's say we're producing a lot of products for OEMs. And then my neck of the woods is hydronics. And here we specify basically in controlling temperatures inside buildings. And you know this the controlling temperatures inside is not only about just a control valve. It's also about the balance in the system, so the water distribution. And this is very much a core of our business. And also we were one of the first on the market with PICV valves, and also we were one of the companies really driving that change in the market. So, as I was saying, we're talking today mostly about HVAC, and here we always see that different, let's say a few different points are actually important. And it's also it depends a bit on the region by region which ones are the most important. But I guess also right now with energy costs rising again, that energy efficiency will be for many people an important part. I wouldn't necessarily say to be green, but it is also although for certain people that for sure is important, but energy costs money and it's getting more and more expensive. So people want to reduce basically their operational expenses. So for sure that is always the point. Then usually for buildings, we want to make sure that the people inside are comfortable and healthy. I mean, there's a lot of studies done on productivity and the combination between healthy buildings, good indoor air quality, and good temperatures, and how this impacts the health and the productivity in buildings. And and that is what basically the building owner wants. But then, you know, if you look at the people that actually are building the systems, they want to be able to, you know, deliver the project fast, on time, on planning, and without any hassle or problems. And that means basically that that usually you have also a good return on investment. I would also say that if you look at the cost for HVAC installations, then building it is only like 5% or something of the cost. Running it is 95% of the cost. So also if you want to really reduce cost in your building and have a good return on investment, then probably, you know, just looking at, you know, the cheapest product in the catalog is maybe not the best way to go. But as we mentioned also before, PICV, PICV, pressure independent control valve, it has been a up and coming product where in many parts of the world this is a rather standard product already. I mean, Europe, basically, you know, Germany, England, pretty much standard. If you go to Middle East, also Dubai, it's a standard product, and that is because it brings you quite a lot of benefits. So where before, for example, it was complicated to size the valves, control valves, is that yeah, more or less, if you go to PICV, it's very simple. It's just basically a selection based on the flow, which you might also get if you're talking about circuit setters or autoflow valves, whatever you want to call them. But proper handling of autoflow valves and circuit setters, usually you need to do some specific flushing procedure and all those things, and that is not how PICVs usually work. They you can flush them without removing any cartridges or something. And you know, also if we're talking about, then I will also come back to, you know, the combination between control valves and autoflow valves, as to why I think it's not necessarily the best idea to do that, provided you want to use modulation on your valve, so 0 to 10 volt signals. And all in all, the PICV gives you a kind of an easy, foolproof way to always get the right temperatures in the building, but also the right differential temperatures. I mean, everything in the building, the efficiency of everything in the building is basically dependent on how much of the energy you're actually pumping into the building, and it can be cooling or heating, but how much do you actually use? And then also, you know, chillers tend to be more efficient with better delta T's, how they're designed, and the same goes for boilers. And all in all, by reducing also pumping energy, all those things, you will get a very energy efficient building, and and also all the equipment, the capital equipment in the building will run at its most efficient, because that is, you know, often also the case. I mean, we spent a lot of time looking at big ticket items, right? So like chillers, they are very expensive, so we will spend a lot of time selecting the best one that gives us the best efficiency for the lowest price. But in the end, if the whole control in the building, if the efficiency in the building or the water distribution and the balance is not correct, then this thing will not deliver what you bought it for, right? It will not really achieve that efficiency. So maybe it's also an interesting idea to just try to explain how a pressure independent control valve actually works. It's as mentioned, it's well, the name is kind of explanatory, and I know from the beginning that we had also different namings like PIBCV and PICCV and those kind of things. But I think the market pretty much settled now on pressure independent control valve, and in a way that gives the game away. It is a control valve that operates the same under all pressures, or differential pressures, I should say. But and how this works in real life is that basically it has two valves inside. So we have the top part. Let me see if I can have a. We have the top part that is here. That is just a control valve that functions like a normal control valve. It will just open and close based on an actuator that's on top. So there is nothing really spectacular. But if you look at the bottom, this is where kind of the magic happens, because that is a pressure controller. So the pressure controller responds to the pressure and actually maintains a constant differential pressure across the control valve. So and I think most of or my understanding is that all of you are control contractors, so I guess you can understand what that means. But just to kind of lay it out a bit more, the flow through a valve is determined by the differential pressure and the CV value, and the CV value is basically the size of this hole. So to know, if we know how big the hole is and how much resistance it generates, and we know the differential pressure, we have the actual flow through the valve. So if we are not messing with the control valve, so the CV value is actually not changing, then, and we also have a constant differential pressure, then we're basically multiplying two constants. And I don't think you have to be a math wizard to understand that two constants also generate a constant. So, and this is how we always manage the same flow. And that means that we have a very predictable flow. We know exactly what the flow is when the valve is fully open. We know what the flow is when the valve is half closed. And that means also we have a full authority on the valve, which is a bit different discussion that I don't have time to go into today. But this is the basic idea behind a pressure independent control valve. It's by keeping the pressure controlling function separate from the control valve, we can let the control valve do its work the way it was intended. So also usually when we have a number of different valves, I will show you the full lineup later, but there is let's say 1/2 inch valve that we have, or actually there are two, and they have a maximum flow. I don't know, could be 4 or 5 gallons per minute. But you don't always need 5 gallons per minute. I don't know, maybe you need 3. So then it becomes a quite simple calculation. You basically calculate what's the percentage that 3 gallons per minute gives you from 5, which is then 60%. And basically you just lift the top and you basically set the flow to the right. Why is it? That is a very simple way. It's also how the whole range works. There's a percentage scale on the valves, you calculate the percentage, and then you basically set it to that. So now finally it wants to do its job. So this is how you do that on the small setting. For the bigger valves, you need a spanner to do it. But for the small ones, this is up to 1/2 inch. No, sorry, 1/3 inch. Basically, you can just use the hand. Also, when you mount a actuator on top, it is also locked, so you can't basically change it anymore afterwards. So unless you remove the actuator, so that is fairly easy and fairly straightforward. So as I was saying, it's pressure independent, and just to drive home the point, these are measurements we took from our valves with a 0 to 10 volt actuator under different pressures. So these are different pressure stages. The different colors are different pressures, differential pressures, I should say. And you see that basically under each and every differential pressure, it's a straight line, and it is it's very predictable. And if you have 5 volts, then you have actually half the flow. If any of you are really into controlling, let's just see if I can remove this one, then you might wonder, okay, but what if I need a equal percentage valve or a logarithmic valve? Well, because we have this very predictable curve, actually we don't do the change from logarithmic to equal percentage in the valve, but we do it in the actuator. So our actuators have a setting on them that gives you linear or logarithmic characteristics, and that means that you can have the logarithmic curve that would look a bit like this one. Also in the same product with the same actuator, so that for as far as stocking goes, that's also easier, stock keeping units. But I would say most of the time you would use the logarithmic setting until and unless you're using water-to-water heat exchange, which does happen, but most of the time these things are for fan coils, air handling units, those things. So what is the portfolio that we have? Well, we go from 1/2 inch to 10 inch, from basically 0 to 1,600 gallons per minute. I think that for most normal HVAC applications and buildings, you would stick somewhere to usually to the 4 inch. That's kind of like covers many of the buildings, but we do have bigger ones, and specifically in, for example, Dubai, where they have a lot of district energy, district cooling. These are also quite popular. So there is a big range, and obviously we also have actuators that fit on that, and 0 to 10 volt, 4 to 20 milliamps, that's all available. So it is a full range of products with a full range of actuators. And so if we're talking about, how and why would we use APQMs, then as I was saying, it is simple to select. Basically, we even have a tool to do it, but I mean, if you have the data sheets with the minimum maximum flows, it's very easy to do. You can basically pick it immediately from the lineup. So we are kind of reducing some of the components. We could say that a normally, depending on what your solution is, but let's say conventionally you would have either you would have a control valve with either a double regulating valve, so something you actually have to measure and set, or a auto flow or circuit setter, and that has two components. I would say two components also need to be installed in the installation, so that also is a time consumption that you have there. Time is money. So essentially, we're putting two functions in one: the balance, the automatic balance in the valve, together with the control, and you always have also the perfect control. I mean, we have demo panels that we tend to show customers quite a lot. Let's say it can control easily and stably to 1% of what it's do. And I would say that for a normal control valve, that is very hard to do, or I would even say impossible. But all right, and then as I would say a new development on PICV, and that's also something we see a lot nowadays, is where we have digital actuators. Digital here meaning that it actually connects directly to your BMS. It has BACnet and Modbus connection both. This also gives you a rather interesting feature. That means that as I was explaining to you the setting, the way that they have to be set, that then also disappears, because then you can basically do the setting from behind the computer and just by using the digital actuator, which also would make it a lot easier to make corrections. I mean, in the building planning and process, often, well, we wanted to have 5 offices here, but now actually we want to have like 3 and a big meeting room. Can you please make it happen? And then, maybe you need a bit different flow. Maybe you need to arrange the valves in a different way. This will be much easier when you have digital access to your actuator. You can also see a number of data points, so you can see the flow through the valve, and if you connect also temperature sensors to it, then you can actually also basically calculate the energy. And that's another part of this, is that by using the Novacon digital actuator, you will also have additional IOs. So the Novacon itself has let's say an analog output, 0 to 10 volt. There is two or three analog inputs. So for temperature sensors, PT1000, PT100, that can be connected also to the actuator. And this will give you a bit of let's say freedom also to work within the application, like where we have if you have, for example, on the fan coil unit, you have 0 to 10 volt fan speed control. You could actually drive that from the Novacon if you wanted to. And another application which is now rather popular also in Europe is what we call 4-pipe changeover. So that means that one heat exchanger, and that's usually a climate panel ceiling, but it could also be a fan coil unit, is doing the heat exchanger there, is doing both the heating and the cooling. And then there's a 6-way valve in between that switches that over. That switching over can also be done directly from Novacon, and it has its own algorithm also built in. Good. And then because I'm a bit of a nerd, I also wanted to go a bit through some technical things just shortly, and also why I don't like auto flow or circuit setter solutions with control valves, to which I have to add if you want to control, actually. So you want to modulate. If you do on off, then it's fine. But let's say the autoflow actually destroys all the authority that the control valve has, and I can kind of explain this with this example. So let's say we have a control valve with a circuit setter here. So the design flow is 2 gallons per minute. The minimum delta P that the autoflow needs to work, or when it starts to work, is like say 2 pounds per square inch, and the CV of the control valve is 1.9. So if we look at what the pressure does, and this is kind of the standard formula to calculate that. If you calculate that, you need 1.11 psi to basically get the flow that we want, right? So we want 2 gallons per minute. If you calculate this formula, you will need 1.11 psi. So that means that since we have 15 available, the rest of the pressure drop actually falls on the autoflow. Because that is its function, right? It maintains the flow. And if the flow wants to be higher, then it will actually increase the pressure drop, or basically close, which means it increases the pressure drop, and then make sure that it doesn't have an overflow. So far, so good. Great solution. And for balance, so at full load, your system will run perfect. The problem with that is that full load is a situation that doesn't really happen that much. Let's say if you usually it's kind of start-up times in the morning, right, when you're going from night setback. So let's be generous, it will be 5% of the time that your system will be running on full load. Which then means that 95% it's running in some kind of partial load. And specifically, if you want to modulate, you want to be able to give your air handling unit or fan coil unit or whatever also 50% of the flow, or even less, 20% of the flow. So now what happens when you start to close the valve? When you start to close the valve, then it means actually that pressure is shifting from the autoflow to the motorized valve. But because what actually happens is the autoflow is opening up. So when you start to close the valve, the control valve, the circuit setter thinks, well, this is not good because I'm not actually reaching my design flow, right? I want to do 2 gallons per minute, but I'm not getting it, so I need to open up. So what happens is that basically the pressure drop moves from here to there, and that means that until you reach the 2 psi, which is the minimum that the autoflow needs to work, it actually keeps up the flow, and only when it drops below 2 psi, it will basically start to lose its bad influence to a certain extent, because the spring will still be a bit loaded. But what this means is if you look at what you need to calculate. So if you have 13 psi there, that means that until you actually reach a pressure that will allow you to reduce your flow under 2 gallons per minute, you actually need to reach a CV of 0.55. So because 0.55 means that your flow is now at 13 psi and 0.55 CV, your flow is now 2 gallons per minute. So you need to drop below that to basically start controlling, because up till we moved all this, let's say 12, 11 something pressure, we moved it over to the control valve, nothing is happening. It will still just give you 2 gallons. And that means that more or less already you have lost 70% of your valve characteristics. So you close it for 70% and then it starts to do something, which probably is not very good also for the control, right? Because the control likes predictability. So nothing happens, nothing happens, nothing happens, nothing happens. At some point, something happens, but then your integration time and all those things have gone rather haywire already. So this will basically gives you on-off control. So if you put a 0 to 10 volt actuator on this valve and you put a circuit setter before it, basically you could have just used on-off here because it doesn't really matter much. So if we're talking PICV, then basically because we keep our differential pressure across our control valve always stable, it's a very different principle. Even though at first glance you think, okay, this is two valves, this is two valves, so what's the difference? But you can see that if we have the same CV value, then we have 1.11, but actually the CV, the control valve, can do what it wants because the pressure is always the same and always stable. So essentially what you will see is that if the pressure controller is if the control valve is closing, the pressure controller is actually also closing to get rid of the additional pressure that otherwise the valve would have. And that means that if you have half your CV, which means the valve is half closed, you will have 1 gallon. If you have 20% of your CV, then you have exactly 20% of your maximum flow, which is 0.2 gallon. So, 10. If you have 10%, then you have 10% of your flow. So that is a very different way of working than on the other side. And I mean, obviously, you could do the same calculation if you use double regulating valve. I would say the advantage of a double regulating valve is that it doesn't open up, so it doesn't actively destroy your valve characteristic, but it will be very it's a bit sensitive to different things that happen in the building, right? If other valves are opening and closing, then the double regulating valve is not an active component, so it will not stop those pressure fluctuations from reaching your control valve, which makes it rather unpredictable. Good. Yeah, so this is kind of my the end. Just to give you a summary. So why do we use it? Well, we have less components. It's easier to work with. It's easy to select. Also easy to commission. There's no measuring needed. You can if you want. We have versions with test plugs, but usually we say don't, but because you will just destroy time and money. This is also a rather reliable product. I mean, the way it works actually gives you always the same results. I will also say that it's not really, as we also opened, this is not really a new product. I think that specifically for the brass versions, we sold literally millions already in the last 20-25 years. It's very much a tested product, even though it's been updated a few times. But so there's no risk of, okay, I'm trying something very new here. And it will give you the right stable control. That means also that you will not have any callbacks to the project because the temperature is not stable in the room, or it's too cold, too hot, whatever. The water distribution in the system will always be correct, and you will have always the right control. A different part also is when we talk about commissioning systems, specifically controls from the control side. often, and usually you would do that if you go to air handling units, you would kind of mess with the pressures with the PID settings, right? Or PI settings to have the right P band and the right integration time and all these things. That if you use PICV, that's also rather a thing of the past. I mean, usually you for a project you can do it once, and then you say, okay, this is fast enough and this is stable, and then you basically can copy the same settings to all ABQMs because they will all basically react exactly the same. And then a new development that is now also coming up strongly is digital actuators, where we have the direct access to the actuator with the building management system. And yeah, which basically brings me to the end um, of the presentation. So let me stop sharing the screen, then I can go to and we can go to the Q&A. I can find
Well,
it.
thank you, Stanley, for that wonderful education here. While you were presenting, we did have quite a few folks chime in the Q&A section. So if you're ready, I'm ready. We can start
Yeah,
going through
let's
these here.
go. In the meantime, okay, you can just do it here. That's also stop sharing. So I'm here. Good.
Perfect.
Shoot.
Alrighty. Well, the first person didn't leave us a name, so luckily you're first, so no pressure there. We will definitely get to this question. Should I control a PICV with drives on the pumps?
Good question. And yes, I mean, you don't necessarily have to, because it will not impact the PICV, but it will impact your energy consumption a lot. So if you don't use the drive, and then you will actually just lose a lot of energy. I would also say that specifically depending on how you use the drive, I know in the US you tend to want to have let's say pressure sensors at the end of branches, right? That is kind of like how it's often done. That will actually, if you use PICV, that will actually give you more savings than if you use normal control valves. It's a bit complicated explanation, but that's more or less the headline of this one. So yes, please use drives.
Now, Stanley, with one of those points that you just mentioned, is that oftentimes because the differential pressure range of these pressure independent valves is lower than some standard control valves? That would allow you to ramp the pump down so you don't have
Yeah.
as much.
Well, it's more on the let's say the reactiveness of the control valve, right? Because if you or of the PICV, so if there's less pressure, then the pressure controller will open up and give you actually a lower pressure than, while if you have autoflow or double regulating valve, it will basically uh, keep the pressure until it drops below the flow. So it is a bit on how the principle works of the PICV PICV.
Awesome, thanks. On to the next one here. What is the lifespan of the PICVs?
Yeah, I guess that somebody looked at it and looked at the membrane and thought maybe that is something that might fail. Well, we've been selling them for 20 years now. We have not had one come back because it was worn out. So that is an answer. I would say also all this technology that's inside is not necessarily new. Basically, the way we combined them into one valve, that was new. But like pressure controllers, and I think I mean also competitors have those, and we had those for a long time. Is an existing technology, and also specifically in what we also a big market of ours is district heating, district energy, and we sold pressure controllers for decades or 100 year maybe, yeah, okay, 80 years. And they were the membranes actually never fail. It's rather a strong component.
Correct. And I think that I'm safe in saying that the entire ABQM line's backed by a 5-year warranty. I believe you'll verify that as well. But awesome.
Yeah, yeah.
All right, on to the next one. Still anonymous. Man, they got a lot of faith we're going to be able to answer all these questions. What is the advantage? What advantage is there over circuit setters? I think you touched on that a fair amount in your presentation there, but
Yeah, so I think let's say one of the thing, or there's a number of them. Let's say if we look at let's say setting up the system, then circuit setters tend to have a fixed let's say cartridge that you need to put inside, right? And actually at the outside of the valve, usually you cannot see what kind of cartridge is inside. And if you do it correctly, you would have to remove that cartridge before you do the flushing of the system. So, and now you can imagine that, I don't know, you have a big building, maybe there's 1,000 valves in there. You have a box of 1,000 cartridges that you have removed from your circuit setter. You flush the system, then now you have to put them back. I don't know. I mean, in Europe, it's rather hard to find good people nowadays. So if you trust your guys to do this correctly, then maybe it's fine. But a mistake is quickly made, because when we see that the same valve, the same size, can have different flow cartridges, then a mistake is rather quickly made. And for an ABQM pressure independent control valve, it's easier. You can just do the setting. And the flushing, basically, we would recommend that you open it, you do the setting of the valve after the flushing, so that you have maximum opening and maximum flow. But you can flush both sides if you want to, and that is a big saving. And then I did the whole spiel just now about the control and how it is. So that is, I would say, for me also the biggest thing, because in the end you want to be able to control your temperature in the room, right? And with ABQM, that is uh, much better than with a circuit setter.
perfect. Thanks. All right, on to the next one. We got one from our own Troy Terrell. Do any control contractors in Europe use a mechanical PICV and as a quasi-flow meter? There would be programming needed to be done, but the accuracy makes it seem possible. You able to use that stem travel data from the valve and the Novacon is that how you guys calculate the
Yeah,
actual?
so essentially we what we do, and this is also a value you can actually read from the digital actuators, is that this is the valve position, and that means if there's enough pressure there, there is this amount of flow. Obviously nowadays also there is a lot of focus on measuring and precise. And so there is also a possibility to, if you want that, to connect a flow sensor directly to Novacon to basically get the data. Because obviously what we are doing when we're talking, uh, let's say the flow measuring on the valve itself, it's not measuring, it's an assumption. And that means that if the pump is down for whatever reason, it will still measure flow because it doesn't know the pressure is too low, right? But we do have solutions if you are really because generally that would be good enough for just, and this is also used in Europe specifically also for identifying hotspots, right? Because in the end, if you have two the same offices, and you have one is having much more energy going there than the other one, then something is wrong. And that is how it's used. uh, if you want to be really precise, but actually, I would say the BREEAM, that is I would say the European counterpart of LEED, actually accepts this as good enough to do the measurements. And if you want to do it more precise and better, we have solutions for that too. Uh, but um, uh, but we can give you the flow together with the temperature sensors. Will give you the energy that goes there.
Awesome. Thanks. All right, next one's from George Huber. Do the Pete's plugs read flow through the valve or differential pressure across the valve?
Ooh, that's a bit difficult. I mean, depends on the size. So for the big ones, so that means 1 3/4 inch and up. So that's the cast iron ones. You can definitely measure the flow. And the smaller ones, this is a bit because the US has a different version than we do in Europe. In Europe, the new version has measurement of the flow, but in the US, we still can only confirm that there's enough differential pressure. So that is a bit of a difference. But for the bigger ones, where also it's more important, we would say you can actually the bigger ones have actually three test plugs. You can measure across the control valve, which will give you then the exact flow. And then also you can measure across the whole valve to see if there is enough pressure for the valve to function. So if you have too low flow, you can also measure the actual available differential pressure.
Cool. All right, got another one from Troy. Do you see a need for control via other methods? In other words, energy transfer, BTU or kWh? Also, how would you compare the pros and cons of a mechanical pressure independent control valve over an electronic PICV?
Hmm. Yeah, so the first part of the question was about sorry, can you repeat the first part?
Uh, the need for control via other
Ah,
methods, like an
yeah.
energy transfer, BTU, kWh.
Yeah,
Yeah.
so we have that option if you want. But to be honest, so far I don't see many people using it because also it's actually adding specifically if you're going to BTU limitation as to it's actually adding another layer of complexity because in the end you don't really know how much energy the room needs, right? Because it's depending on what the sun is doing or how what outside temperature is. So we see that most of the people are still just using standard PID with control, but the option is there if you want it. But to be honest, again, it feels a bit overcomplicating things. Then I didn't want to touch electronic pressure independent, so EPIVs, because, well, um, it is also, again, a very complicated topic. It's its own 20, maybe hour-long presentation. But in the end, what the difference is between an EPIV and a mechanical PICV is that the EPIV does the same thing with one valve. So there is only one valve in this loop, and basically there is a flow measuring device, and that takes the signal from the controller, whatever it is, and then the signal from the flow measuring device, and then tries to get there to the setting. The problem with this is that it's not really pressure independent because you can imagine that the control valve, if it needs to compensate for a high differential or available pressure, that it needs to be closed much more. And that means that what you will see with electronic pressure independent valves is that they tend to be very much operating on a very low openings, and for this reason also most of them are quite of not so precise because they want to slow down the control algorithm, right? Because we can imagine that if you have a very small opening, that just a small movement of the valve will actually generate a lot of difference in flow, and therefore usually they don't even respond if the flow is within plus minus 10%. So again, it's a very long explanation, or it's a rather involved explanation, but the control, while the measuring, for sure, the measuring of the flow is much better than what we can provide, but the control that we have on PICV is much, much better, and that is yeah, that is due to, let's say, mechanical limitations on the valve.
Perfect. Thanks. I'm going to jump around a little bit here, and for the sake of time, condense two. We've got two from George again. Will the small US valves have the three PT ports in the future for flow measurement? And also, do these valves meet the Buy American Act?
That last part I don't know. That seems more like a math question, um, but the first part is that no, there will not be three test plugs on the small valves, but there will be at some point we will switch over to the new because we need to cut new threads on the because that's the biggest hurdle usually is that we use ISO threads and you use MPT threads and so we need to cut new threads on the valves, which also needs different but but then you will have two test plugs, but you will be able to measure the flow then. But when that will happen, I hope this year, but it depends a bit on R&D resources, which are hard to come by nowadays. It's and you would think just changing the thread would be easy, but
That's
yeah,
fine.
it's rather complicated. Yeah.
So, yeah, I think just for everyone, the half-inch through inch and a quarter at this time do not have PT ports on the smaller threaded versions. As far as the Buy American, I know, and Stanley, please correct me if I'm wrong, but most of these valves are built in Slovenia. And I believe that is at least a Buy American or TAA compliant country. And just in past, we've just had to get compliance letters. I'd say it would have to be very important for us to have a lot of the project details. I know that if the valve spend is a certain percentage of the project opportunity, sometimes we're able to sneak those things through. But the best I can say is just reach out to us with those questions. We'll happily, and that's our VNA Advantage team. Our valve team will happily jump in and work with Danfoss to confirm if we can meet those requirements for you.
And,
All
so
right.
yeah.
Got a few more here. One from Patrick McKinney. With the communicating Novacon valve, does it inherently sense flow or does that option need to be added? And with the built-in I/O, does logic reside in the actuator? In other words, will we be able to have the valve control to temp set point for condenser water riser diversification? Boy, we jammed in a lot of words there. Thanks, Patrick.
I think that I get the question. Yeah. So uh, yes, all this logic is included in the digital actuator, and there's also a number of logic loops that will give you, uh, for example, delta T control. So you can say set a certain delta T, you can set a certain return temperature. Those, let's say, that logic algorithms are already there. And for example, also if you connect, for example, two temperature sensors, supply and return, it can also, let's say, internally calculate the actual energy that's being used by that application. So a lot of the logic is already there.
Perfect. Now we get one from Marian. Is a Y strainer required, and what filtration is recommended upstream of each PICV?
Well, this is always a tricky question. I would say that it's not super necessary to have a Y strainer in front of every valve. The valves themselves are, which is maybe another advantage towards circuit setters, not super sensitive to clogging, because the problem with circuit setters is they have this kind of like cartridge that basically compresses, and then it can create, specifically at high pressures, very small holes. For us, that is much less of a problem. But so I would not necessarily recommend Y strainers in front of every ABQM, but of course, the water needs to fulfill some kind of standard, right? I mean, it should not be just sludge going through there, and then because you can block everything. So that's, but it's not super sensitive, I would say.
And I will say our exposure to this type of product and really any pressure independent valve, especially when it's in a retrofit situation where you're not quite sure what the system's like, we would recommend the use of at least the process of flushing or back flushing some of the stuff that's already in place. But yeah, just use an abundance of caution, because if there's a ton of junk in the line, that will just make a miserable day for everybody.
Yeah. So that's I can support, right? This is just, I mean, if the water is maintained properly and you know it was clean when you started, so if it's a new system, you flushed it and everything, you don't need it. Maybe, yeah. I mean, specifically retrofit, if there's a lot of magnetite inside or maybe a lot of other junk, then probably it's a good idea. But yeah,
And I
it
believe
depends a bit
that this is
situation.
going back pretty far in my memory bank for you guys' product offering, but I believe you guys have a flushing T kit that you can supply with these that will allow for that to be achieved.
Actually, I
Ooh,
don't know. It's
I'll, I
because
can.
I do know we have for differential pressure controls we have that for the ABQM we didn't really need one as far as so far, but it is possible, by the way, which is maybe what you're referencing to, is to unscrew them at the bottom part of it and clean them if you want to, and that could also mean a new membrane with a new spring, but for the smaller sizes, right? But as far as kits, that I don't remember actually. But
Perfect. Well, if you have questions about that and you want to learn more, I'll chase that answer down.
I will ask you.
Yeah. I got another one from Patrick. Beyond price, what sets this product line apart from comparable competitors on the market?
Well, there's always a lot of discussion on what's comparable and not. I would say an EPIV is not comparable in the sense that I went to some length to explain. There's a number of other competitors where we say, okay, or there's a number of competitors that basically give you a circuit setter and a control valve in one body and then call it a PICV, which, as I was also explaining, is not. And there are a number of others that also do it properly. I think one of the things that we do better than others is we have a very precise control. We make our own actuators also in the same factory in Slovenia, and that means that also our actuators have a perfect fit. There's no dead times. There's no gaps or something in the control. So you will find that ours is the best controlling valve on the market, and I guess you are buying a control valve to do controls. So
Perfect. I think we have time for maybe just one last one. Do you think PICVs require different filtration requirements for the systems when compared to CCVs?
I guess we kind of touched that. I don't think no. Actually, I would say no. I would say circuit setters are more sensitive to this, but if you have let's say a regimen that works with circuit setters, then it will also work with PICV. There's no need for it to be any more let's say rigorous than what you're already using.
Awesome. Well, thank you, Stanley, for this education and for fielding all these questions. Just for everybody on the call, as a reminder, when we wrap up here, we'll be raffling off 3 Danfoss swag prizes that include a ball cap, travel mug, safety glasses, touchscreen gloves, and more. We'll randomly pull 3 names from the list of attendees, and your Alps Control sales rep will reach out to you if you're a winner. Also look for a video replay of this event on the Alps Controls YouTube channel. We'll post it within the next few days. Thank you, everyone, again for attending. If you have any questions, feel free to reach out to us, and we'll happily support you the best we can.
All right. Also, thanks on behalf of me, and maybe we'll see each other soon.
Sounds good. Thank you, everyone.